For end-to-end models, many aspects are essentially a black box to us, so their interpretability is relatively poor. I'll use a video to explain this clearly. For a complex task, we usually break it down into several modules. For example, given an input, we pass it through multiple modules before getting an output. This means solving one problem first, then building on it to solve the second, followed by the third, until we get the final output. This problem-solving approach is a common and intuitive method. Conversely, there is another method where we take an input and directly produce an output in one step. Here, we can imagine that each box in the process represents a model. With this method, we only need a single model to convert an input into an output, unlike the modular approach, where we connect several models linearly. This second method is what we refer to as an end-to-end solution. Let me give a specific example: simultaneous interpretation. Here, the input is a user's speech, let's say a spoken sentence. Next, we need to convert this speech into text, a process called speech recognition. This text might be in Chinese, but the goal is to translate it into English. This step, converting Chinese text into English text, is what we call machine translation. Afterward, we need to convert the text into speech to deliver it to the other party, a process known as TDS, text-to-speech. This workflow represents a classic pipeline, consisting of multiple steps and involving different models. If we want to transition to an end-to-end approach, we need to build a model that directly converts Chinese speech into English speech. In this way, a single model handles the entire task. Now, let's consider a multimodal scenario. For instance, given both text and images, we want a model to generate an explanation of the image, returning a descriptive text. This is similar to GPT-4o's functionality. The input text can serve as a prompt, instructing the model to explain what the image contains in terms of people or objects, and the output text lists these objects. Following the earlier logic, we could easily build an AI system. For example, we input both the image and text into a large language model. Text, being inherently compatible with large models, can directly serve as part of the prompt. However, images differ from textual data. A common approach is to encode the image, then use a small adapter to transform the image representation into a textual representation, which can then be input into the large language model. The model would then output the desired answer. Alternatively, an end-to-end approach requires designing a model capable of taking both images and text as direct inputs, and then generating the output text directly. This type of model is what we call an end-to-end model. Another example is designing a robot to pick up trash. In the traditional approach, we use visual algorithms to first identify the location of the trash, such as its 3D coordinates. Then, the robotic arm is controlled to pick up the trash, dividing the process into several steps. In contrast, an end-to-end approach would directly use visual input to drive the robotic arm to locate and pick up the trash. Let's briefly explore the pros and cons of end-to-end models. The advantages are: first, the latency. End-to-end models typically have lower latency since the task is completed in a single step. This makes them a preferred choice for real-time AI systems, explaining why GPT-4 can efficiently generate images or text. In contrast, standard pipelines often introduce more latency. Second, the performance. In terms of accuracy, end-to-end models often outperform standard pipelines, provided they are well-trained. In a standard pipeline, each stage driven by a model has its own error rate. When we decompose a complex task into multiple stages, the cumulative error rate increases, potentially leading to unsatisfactory results. Third, flexibility. For new task types, standard pipelines might require significant modifications, which can be costly. End-to-end models, however, often just require collecting new domain-specific data for further training. The disadvantages are: first, the training difficulty. End-to-end models are harder to train because all signals must be combined into a single model, requiring more training data. Second, the interpretability. End-to-end models are often black boxes, making them less interpretable. For standard pipelines, it's clear what each step does. However, with end-to-end models, if the model performs poorly or exhibits issues post-deployment, diagnosing the root cause is much harder. In summary, the choice between end-to-end models and standard pipelines depends on the specific problem. From a developmental perspective, however, there is a growing preference for building end-to-end solutions.